So with this problem right here, we are looking at a copy machine. We've got two copy machines, with the first and the second. So I'm going to first of all kind of distinguish between how many copies the first one makes, how many copies the second one makes. So there's copy machine 1, there's copy machine 2. All right, and this is just going to be where I do my work. All right, so how many copies per minute can the copy machine 1 make? This is an open question. Anyone can answer. So what's the number of copies per minute for copy machine 1? 60. It says it right there in that first sentence. All right, so that we'll call that one copy machine 1 because here's now the second copy machine. And we can see that that makes 80 copies per minute. So I'm just going to put that copy per minute, copies per minute. Now, if you don't write down the units, that's okay. They're not asking for that at the end. So it's just to keep it straight as you're paying attention. So what we want to do is figure out how many minutes are these copy machines running, and then we can just multiply that together. All right, so I'll multiply that by the number of minutes. Now, it says the second machine starts making copies 2 minutes after the first machine starts. Both machines stop making copies 8 minutes after the first machine started. So how many minutes did the first machine run? 8. You can see right here in this sentence, if they both finished 8 minutes after the first machine started, the first machine was running that full 8-minute time. So times 8 minutes. And now we can see the benefit of seeing the units here is that 60 copies per minute times 8 minutes. We can just kind of cancel those units out and we get 60 times 8 is 480. That's just something you can quickly plug into your calculator and get the answer for. So how many minutes did copy machine 2 run for? 6 minutes. There we go, because it started 2 minutes after. So that means only 6-minute run time. You can copy those out, cancel those out, multiply, and we get 480 again. They both made 480 copies. One did it in less amount of time. Add it together because we have two different copy machines, and that gives us the 960 copies total. Okay, pretty straightforward on that once you can set up the equations and understand what's going on. Okay, so today we're just going to get some practice with the 30, 60, 90 triangle, and I'm not going to introduce anything new, except, let me pause real quick. I do have printouts of the reference sheet, so I will pass those out to everyone here, but I will tell you at home, if you can access this, and you can on Canvas, so all you have access to it, but if you want to make a physical copy of this by like copying it down on a sheet of paper, it won't take too long to do that. It might be good to have a physical copy. If you have a printer at home, of course, you can just print it off. If you don't mind switching back and forth on the iPad or pulling up a split screen, that's also a possibility. But I've got these references now available, so I would highly recommend keeping those handy every minute that we do these kinds of problems. So with that reference, we're ready to move forward. Your homework is going to be another PDF that's on Canvas. And just real quick, a comment I want to make, because some of you still are missing most, if not all, of the assignments for this class. And what I would recommend is set a goal for yourself today to, during class, finish 2 assignments. Maybe you finish this triangle practice that I assign you now, and then you find one of the delta maths that you haven't done yet. If you can get 2 of those done in class today, that's a good place to go. Like, just do 2 every day until you get caught up. And those of you who are caught up, of course, you don't need to worry about that strategy. Just get today's work done. But let me now get out of this. Actually, I don't need to share this anymore. And I will bring up this and share the screen. No, yeah, there it is. And what we've got is, it's a worksheet that looks awfully similar to the one you did 2 days ago for 45, 45, 90 triangles, but now we're looking at 30, 60, 90. With the last homework, I had you do all the odd problems. Now I'm going to have you do all the even problems. So I will run through some of the odd ones. And I'm not going to fully create the the reference for the 30, 60, 90. I'm just going to give the really brief one, which is going to look like this. I will draw a 30, 60, 90 triangle. So there's the 60, here's the 30. And if the short leg is x, then 2x is the hypotenuse, just 2 times whatever length you have for the short leg. And x times the square root of 3 is the long leg. All right, but a lot of time today, I am going to refer back to the reference and point out which formula I'm using. So let's go ahead and get started with this. I've got which side of this triangle given? The short leg, long leg, or hypotenuse? We're looking at number 1. The hypotenuse is given. We need to solve for both the short leg and the long leg. And when we're looking at a 30, 60, 90, we have a specific order we need to go in. If we know one of the long leg or hypotenuse, we need to go kind of around we have to do the short leg first. That's the essential thing. If we know the short leg, then there's no order. It doesn't matter which one we do first. And we'll have an example like that too. So the first thing I need to figure out is if I know the hypotenuse and I'm solving for the short leg, then I can use this formula right here. Short leg equals a hypotenuse divided by 2. And this, you can find it right here at the very bottom left of this page. So the idea is if you know the hypotenuse or you're trying to solve for the hypotenuse, you can use one of these 2 formulas. Okay, so that's the one I used. And now the short leg is given as b for this particular problem. This is where I'm getting that from. And the hypotenuse is given as 4 square root of 3 divided by 2. Now this is the weird thing, because at this point, we want to take 4 square root of 3 over 2 and then divide that by 3. Well, there is a different way of writing this. Dividing by 3 is the same as multiplying by 1 over 3. And we already saw this the other day. But I just want to remind you, rather than doing over 3, I'm going to do times 1 over 3. And now this makes it pretty straightforward as far as it goes. So 4 times square root of 3 over 1 is going to be 4 square root of 3. And then 2 times 3 is 6. And I can actually simplify that, can't I? What could I simplify that to? Is there any common factor between those 2 numbers?
2.
2, very good. So we could divide both these by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. All right, so 2 square root of 3 over 3. And let me mention this real quick. I actually forgot to simplify it from there in first hour. So this is something I'm looking at it a second time and saying, oops, I forgot to do that. Now, if you do the same thing on the test, I do actually look at all your answers. I don't just see what the computer tells me and then give you that grade. So I look at your answers. So if you came up with 4 square root of 3 over 6, and you put that in as your answer, and you didn't simplify it to 2 square root of 3 over 3, then you at least get partial credit because you were on the right track. You just forgot to do the final step. So don't worry about if it says initially that you missed like X number of problems. You might get some partial credit back if you knew what you were doing and you just missed one little step along the way. So anyways, that's the answer for B is this. We cannot simplify that any further. Now that we know that this is 2 square root of 3 over 3, then I can now find the long leg. And I need to look at my reference, look at my diagram right here, whatever works. So if I know the short leg and I'm trying to find the long leg, then I can use this formula right here. It's the one on the top on the left side. So it says the long leg equals the short leg times square root of 3. All right, now the long leg in this case is A, and the short leg we just calculated is 2 square root of 3 over 3. And I'm going to multiply that by square root of 3. Now, this is another thing that we saw yesterday, and I want to remind you, if you have this weird thing, anytime you're multiplying by a fraction by a non-fraction, you can turn this into a fraction. And we've done this a number of times. I just want to remind you, that's just the same as square root of 3 over 1. And this will make your life a little bit easier. Multiply across the denominator, that's easy. That's 3 times 1 is 3. 2 square root of 3 times square root of 3, what is that going to be? 9. Well, yeah, under the radical, it's going to be 9 right there. We need to now recognize that we have a perfect square under the radical. So the square root of 9, we've done this enough. We know that that's 3. So we can multiply that out and get 6 over 3, or we can recognize that these two are just going to cancel out. And just as a reminder, if you have 2 times 3 divided by 3, essentially this is the expression that we're calculating. 2 times 3 divided by 3. So if I multiply by 3 first and then I divide by 3, well, they just cancel each other out. But we have to be careful. Multiplication and division will cancel each other out. If this was, and you'll see equations like this when you get to algebra 2. If you had 2 plus 3 divided by 3, you can't cancel out because addition and division are not the inverse of each other. So just kind of keep that in mind. And you're going to get all kinds of fun with rational equations later. Anyways, the answer is 2. So there we go. I will pause at the end of all of this. If you want to take pictures of your screen to have this as reference, you might come across another question like this, and you might want to look back on it. If you have any questions, of course, now is a good time to ask them, or maybe this is also a time where you can make a note to yourself to get some help with this later. Okay, I'm going to go ahead and start erasing, and then we will look at, I don't know, 3 or 4 total problems. And then if you need more help from there, we can go at that point, figure it out. All right. So let me see. I'm going to skip this one. We'll do number 5. All right. So the information that we have, that 9, is that short leg, long leg, or hypotenuse? That's hypotenuse again. So it's really the same process, but now the number at least starts off looking a little bit nicer. So I'm looking for the short leg, and I know the hypotenuse, so I'm going to do the hypotenuse divided by 2. All right. So the short leg that I'm trying to solve for is called y. Again, I'm pulling that from the diagram. The hypotenuse is 9 divided by 2. And I wanted to go through this one just so you know. And I think we saw something like this yesterday. When you get to this point, just call it 9 over 2. We're done. That's all there is to it. So we're good with that. Now I want to figure out the long leg. And that's just the short leg times the square root of 3. So we're using the same 2 equations that we did on the last problem that we went through. We're just, start with, we have a different starting value. So the value I'm looking for is x, which comes from the diagram. I've got 9 over 2 as my short leg. And I'm going to multiply by square root of 3. And just like we did before, square root of 3 can be written as square root of 3 over 1. So now it's 9 square root of 3 over 2. And again, this doesn't look very pretty. In fact, it just seems to get more and more complex and uglier. But this is as simple as we can go. There's no common factor between 9 and 2. The square root of 3 doesn't have anything. We can't simplify that any further. So that's our final answer right there. Okay, again, I'll pause right here if you want to take a picture of it. All right, so I wanted to run through this problem because, like I was saying, the 9 being right here as what's given, it might look like it's going to be pretty simple. And I hope you think it is simple, but it does get kind of some ugly numbers. So maybe there's a general rule we can keep in mind that if you start with really nasty looking numbers, you might end up with a really simple number at the end. If you start with a really nice number at the beginning, it might get kind of messy at the end. All right, let me erase this and move forward. All right. Let's see. I'm going to skip this one because that's kind of what we just did. I did want to run through a few of these. Let's start with number 9. All right. Again, this is actually, well, actually, number 9 is actually very similar to number 1. It's just now we have 26 up at the top instead of 4. So honestly, you could do number 9 the same way that we did before. But let me look at this. Okay, this is one I definitely want to go through. Number 11. The reason is now we're looking at the long leg. All right, so we are given the long leg. We need to solve for the short leg and the hypotenuse. So let's run through that. Zoom out a little bit so I have some room to work. All right. So knowing that I have the long leg and I'm solving for the short leg, that means that the short leg is equal to the long leg divided by the square root of 3. Again, I'll just point out that's this equation right here. So it's the first group of 2 equations, and that's that. So how do I know to use that one? It says if you know the long leg or want to solve for the long leg, use one of these 2. And I could have used either one of those 2 equations. It doesn't matter. But this is one that's set up nicely. So now my unknown is going to be on the left. The long leg is 3 square root of 3 over 2. And rather than saying over square root of 3, instead, I'm going to write that as times 1 over square root of 3. So this one starts off pretty nasty looking with that number, but we can see what happens right away. When I multiply across 3 square root of 3 over 2 square root of 3, and what happens here? Okay. If this is what my equation looks like right now, 3 square root of 3 over 2 square root of 3, is there anything we can do to simplify this? Okay, and that's a good thought. We could rationalize the denominator, and in a regular situation, we would need to do that. But luckily, we've got the same radical on top and bottom. So is there anything simpler I could do? Yeah, just cancel those out. Is that what you're going to say? All right, so you got it. So yeah, in this case, we lucked out. We don't have to rationalize the denominator because we can just cancel out, and we get 3 over 2. So now we're making this a nice simpler number. So you get 3 over 2, and now we want to solve for the hypotenuse. The hypotenuse equals the short leg times 2. And all right, the hypotenuse is x in this particular problem. The short leg is 3 over 2 times 2. And I'm going to write that as 2 over 1. We can always write a number as a fraction. If it's a non-fraction, just put it over 1. And now we got 6 over 2, which makes 3. All right, so here's a point where we're done with the problem. You can take a picture of it if you'd like, if you think it's going to be good to have that as reference. And are there any questions on this? All right. Now, my hope is that as you're running through this, you're saying, okay, it's not so bad. I can understand these rules. Tomorrow, we're going to incorporate both the 45, 45, 90, and 30, 60, 90 together. And that will be, where you're gonna have to tie it all in, and hopefully that doesn't come off too bad. All right, let me erase. There it is. And let's see, I know I wanted to run through a few more. Let's go with 17. This one starts off really nice. And we can see that sometimes if we start off with a nice number, it ends up as a not very nice number when we're done. So I'll go ahead and have you guys answer. Is it short leg, long leg, or hypotenuse that they give us? Long leg. There it is. So knowing it's a long leg, now this is where we get to solve for the short leg first. The short leg is going to equal the long leg divided by the square root of 3. The short leg is n. The long leg is 8 divided by the square root of 3. And this is where we're going back to what you were just mentioning a second ago, Dalen. So this is where we need to do what?
Multiply the bottom square root.
There it is. Now it's rationalizing the denominator. Square root of 3 over square root of 3. And now we get 8 square root of 3. And I'm just going to skip a step. If you want to do this, that's fine. Square root of 3 times square root of 3 just becomes the whole number 3. Now what it becomes in the intermediate is square root of 9, and that just becomes 3. So that's the idea. So now this is the short leg. I cannot simplify that any further. So 8 square root of 3 over 3. And to get the hypotenuse, I have to take the short leg and multiply by 2. So that's going to be m equals 8 square root of 3 over 3 times 2 over 1. Again, I'm doing that same trick, just turning it into a fraction. It's over 3. What's the numerator here?
Times the square root of 3.
There it is. The only things that multiply together are the whole numbers. 8 and 2 will multiply to give us 16. That square root of 3 just kind of hangs out. So there it is. We cannot simplify that. So just to make sure that's clear. 16 square root of 3 over 3. Okay. And let's do one more problem. Maybe you don't need it at all. You totally got the hang of it. But let's just run through one more. Just for old time's sake. Let's look at, I actually want to look at, I mean, I don't know if 13 or 15 looks more complicated to you. Let's go ahead and do 15. Actually, it's essentially the same problem, but 15 looks more intimidating because it's got that fraction. All right. So in both of these, I should point out, they give us the short leg, and we can see that. So we're going to be doing essentially the same thing in each one of these problems. And that is, we're going to have to solve for the long leg, which is just the short leg times the square root of 3. And we have to solve for the hypotenuse, which is the short leg times 2. It doesn't matter which one we do first in this case. So whatever, I'll just do the long leg first. So the long leg is v. The short leg is 13 square root of 3 over 3. Now I'm going to multiply. The only thing I'll do different between this and number 13 is that number 13, it wasn't a fraction, so I could just put square root of 3, but I'm going to change this to square root of 3 over 1. Now I've got, I'll put it down here. Now that equals 13 times 3. Remember the square roots of 3? I just multiply them together and they become the whole number 3. I skipped a step in between, but that's the idea. Over 3. And now this is where I can just cancel that out. I know I went through that one a little bit quickly, Do you guys need me to go slower, or you feel like you got it? So 13 is the answer for the long leg. Okay, and now we can do this next one. This is going to be U is the hypotenuse. The short leg is 13 square root of 3 over 3 times 2 over 1, which gives me 26 square root of 3 over 3. I cannot simplify that. And that's not a very pretty looking answer, but that's what we've got. So that is as much as I'll do today. If you have questions, if you do want to see some more, let me know. But besides that, you can have yourself a wonderful day, and I will see you tomorrow. You can log off at this point.